Okay, good morning to everyone. In the previous class, we were discussing about the deoxygenation and reoxygenation curve. That also we have discussed in detail. What is D naught, what is DT, what is DC, and what is TC, what is XC, what is X, and what is T also. So D naught it is uh, DO at zero time, DT is DO at time t, and DC is critical DO where the dissolved oxygen is completely zero, where uh, the aquatic life will not survive. The TC, that is the time taken uh, by the river to reach the critical DO. Then that is a XC means that is a distance at critical DO. So then in that we are going to classify some of the zones. That is zone of purification. First one, when the sewages or the industrial wastewater is discharged into the river, a succession a succession of a succession of changes in the water quality that is going to take place that we already discussed. Either it is a sewage or it is an industrial wastewater. We can take this as the sewage or it is a wastewater. If the sewage is emptied into a lake in which the currents about to fall are sluggish or shift their direction with the wind, the changes occurs in closely um, to each other, and as a result, the pattern of changes is not displayed distinguished. Means what will happen is that suddenly we cannot decide at that point this is going to happen. Means it may takes its own time to change its pattern, or it will travels it changes some distance to change its quality. That we cannot determine on a single stretch. If on the other hand the water moves steadily away from the outfall means normally outfall, you can see that this is the outfall point. Means at that point where the wastewater is discharging or the sewage is discharging. If on the other hand the water moves steadily away from the outfall as in a stream, the successive changes occur in a different river reaches and establishes a profile of pollution which is well defined that we already discussed how exactly the DO-SAG curve is going to happen with some of the rivers and how exactly it is going to happen in a flat manner as it travels. However, in most of the streams, this pattern is by no means static. Means it depends on the kind of river, how exactly it is happening. It shifts longitudinally, means along the length, along the stream, and it may be modified intensively by seasons as well as the hydrography also. It may changes as I already discussed at this point. Summer season, how exactly the pattern is going to happen. The rainy season, how exactly the pattern is going to happen, and winter season, how exactly it is going to happen. Because the DO versus temperature, we already know that how exactly things are happening. Then, when a large uh, scale of sewage is poured into a clean stream, assume that it is completely clean, the water becomes turbid. First, what exactly things are going to happen inside the water that we should know. The water becomes turbid, the sunlight is shut out of the depths, and the green plants uh, which by photosynthesis remove the carbon dioxide from the water and release the oxygen to it. And sometimes some of the plants or aquatic life is going to die off also if the photosynthesis is not happening. Depending on the stream velocity, the water soon turns nearly black. That black we can call it as what the critical DO. That is nothing but this is the point what we are talking about. This is TC and XC uh, and DC. This is small t actually. This is small t that we already discussed. The forming a sludge. When it is forming the sludge means you assume that it is the solids are settled at that point and it is reaching at XV point and where the DO is completely zero. The settled solids soon decomposes, forming a gases such as ammonium and carbon dioxide and methane or the marsh gases. See, some of the Bangalore lake you might have observed um, uh, that when you the bubbles are forming and the foam it is forming in some of the lakes. That is mainly due to this activity only. Whenever if you give or it is catching the fire, um, some of the rivers are catching the fire. You might have observed that is due to this activity. Means the rivers are the ponds are completely polluted. Means the DO is completely zero, and whichever the sludge or the solids which have settled, it is decomposing. Once it is decomposing, the ammonia as well as the carbon dioxide and methane gas is forming. Of course, we know that the methane gas it is combustible in nature. Suddenly, when it comes in, whenever the temperature is go on increasing, suddenly it will catch, sir. Somebody, if you just with the help of some of um, the catch firing sticks, if you might have used that, then automatically it will start uh, glowing. Then this is nothing but this is the activity which is going to happen in that critical DO point. Some of the scavenging organisms increases in numbers until they match the food supply. Then for this, whatever the activity, the marsh gas or the carbon dioxide, methane gas, it is due to some activity that is anaerobic bacteria are responsible for creating this kind of things. The oxygen resources are drawn upon heavily and when overloaded become exhausted. Sometimes what will happen is that whenever the organic matter is going to over, it will take its own time to recover. And when the load is over, automatically it will become stagnant. And when it will become stagnant, then automatically DO will recover when the bacteria are going to die. You might have seen how the bacterial growth curve will be there. Initially, if I draw this, initially this is the log phase, this is a constant phase, and this is a depth phase. Log scale, there is a maximum production of the methane as well as the carbon dioxide, where the bacterial activity also very high. At constant phase, there is a production of constant carbon dioxide and methane. And when it is going to decrease, that is a death phase. Usually, one or the other bacteria are going to eat one another, and there will be a less available of organic matter, and it is going to die, and all the bacteria are going to die. So then, life in such waters is confined to anaerobic bacteria that I already discussed. So there is larvae of certain insects such as mosquitoes also, some of the worms also going to present in that areas. And this is very important. There is no fish, aquatic life will not be there. This zone we can call it as zone of degradation. Completely what we are targeting, that is zone of degradation. So in the second zone means whatever the curve we already discussed in the previous, this is how the curve is there. At some point it will reach, then it will be like this. So this stage we can call it as zone of degradation. Means the DO will go on decreasing. Here it is zone of decomposition, and this is zone of recovery. Means slowly it is recovery. The second zone is zone of decomposition that I already discussed. More solids will settle, water becomes somewhat uh, clear, and sunlight penetrates the surface. then oxygen is absorbed from the atmosphere. Actually, slightly it will be clear. It is not 100%. You can say it is 5%. 5% it is clear. Then oxygen absorbed from the atmosphere at air-water interface, permitting the establishment of aerobic conditions. This is going to be in aerobic conditions, not anaerobic. The zone of degradation is slightly towards the anaerobic process. Here it will be aerobic process. The aerobic bacteria continues the conversion of organic matter into the nitrates, sulfates, and carbonates. So there you have observed some of the things like the production of the carbon dioxide, methane, and some of the sluggish gases. But here in this case, you can see there is a conversion of the nitrates, sulfates, and carbonates. This is for the aerobic bacteria. So this together with the carbon dioxide produced by decomposition as well by bacteria. But this decomposition, whatever the carbon dioxide, it is very less. With the sunlight, now it is penetrating with the water, and with abundance of food, algae will begin. And you can see in this layer, green scum over a surface. This is one indication. If the greens come over the surfaces means slightly decomposition is happening. Then the third zone, that is a zone of recovery. Zone of recovery. This is what I said is that, so this is zone of degradation, zone of decomposition, then slowly this is zone of recovery. If you consider first, second, and third zone, means slowly the oxygen, whatever it will be there, it will come in contact with the atmospheric oxygen and dissolved oxygen go on increasing. So then, whatever the algae becomes more numerous and self purification proceeds more rapidly. Here, whatever the zone of recovery, what we are telling, it is um, um, slowly it is going to increase. The green plants utilizing the carbon dioxide and the oxygen will be liberated in same. Means if even in the ponds, if some plants will be there, it will utilize the carbon dioxide which is produced earlier, then it will start liberating the oxygen. Automatically the oxygen content in the river it will go on increasing, as well as it travels the atmospheric oxygen will also penetrate into the water. Simultaneously the fish that acquires a little oxygen such as catfish and carps also found. As the dissolved oxygen increases, more types of fish appears. Slowly it will appear. After recovery, the zone of clear water zone. Fish finds the stream highly favorable. If the fish are there means it is clear water. If the fish is not there means it is the stagnant water and it is not good for health. As the algae supports various aquatic insects, other organisms on which the fish feed, the water is clear, the turbid according to the concentration of algae. Then in the overall we classify these zones. First one is zone of degradation, then zone of decomposition, then zone of recovery, then clear zone. So this all you have to discuss with the zones. Then this biodemixture we will discuss in the next class. Thank you.